In this video, we're going to be looking at rates of change and slopes. If you find this video helpful, share, like, and subscribe. Rate of change and slopes. Rate of change allows you to see the relationship between two quantities that are changing. If one quantity depends on the other, then the following is true. The rate of change is going to be the change in dependent variable over the change in independent variable. Okay, also that is what we call, this is actually your y and this is your x. Also, we can say that this is going to be a change in y over the change in x. Now, remember always that your y is your output, or also it's called range, and your x here is called your input, or also called your domain. Okay, so now you have a little knowledge on what rate of change is all about. So let's look at letter A in here. Find the rate of change using the table. So we're going to be using this table. Okay, so if we're going to scrutinize the table properly, we can see the change from 2 to 1, that's only 1. 3 to 1, 3 to 2 is still 1. 4 minus 3 is 1, and that's going to be 1. Now from here, from 75 to 60, the change is 15. 90 to 75 is also 15. 105 and then 90 is 15, and 120 and minus 105 is also 15. Okay, so let's answer number 1. So as we have scrutinized the table earlier, we can see that they have, it actually has the same equal interval. This is called the interval. Okay, in here the prices are also the same and the interval is also the same, or we call it constant. Okay, so for number 1, for the data at the right, is the rate of change for each pair of consecutive days the same? Well, we can see that the consecutive interval is the same, which is 1. So answer is yes, they are the same. Number 2, what does the rate of change represent? So this one represents the change of price per day. Okay, we call it change of price per day. And that change of price is around $15 per day. So let's see, find the rate of change using day 5 and 2. Day 5 and 2. So what we can simply do here is actually subtract 120. That's going to be 120 minus 75, and then over the days 5 minus 2. So if you're going to continue with this, 120 minus 75 is actually going to give you 45, and 5 minus 2 days is going to give you 3. This is actually days, and this is going to be $45. So it means to say 45 divided by 3 is going to give you $15 per day. Okay, number 4. Does finding the rate of change for just one pair of days mean that the rate of change is the same for all data? So as we are going to look at our data in here, so we can actually see that all the rates are the same. So to answer the question, does the finding the rate of change just for one pair of days means that the rate of change is the same? Yes, they are constant. So in other words, so they are actually, the intervals are the same. So we can say that the intervals are the same, are the same. So let's see. Example, if you're going to be looking at the number of days, if you're going to look at the difference from The second day to the first day, that's going to be 2 minus 1. It's going to be 1. And so on with 3 and 2, 4 and 3, and 5 and 4. Now, for the rental charge, if you're going to look at it, if you're going to subtract 60 from 75, that's going to give you 15. If you subtract 75 from 90, it's still going to give you 15. And if you're going to subtract 90 from 105, that's 15. And still, if you subtract 105 from 20, that's going to give you 15. So they are actually constant. Constant means they are the same. It's not changing in any way. Okay, letter B. So let's look at this one. Finding the rate of change using a graph. Here, the graph shows the altitude of an airplane as it comes in for a landing. Find the rate of change. We'll explain what this rate of change means. So if you're going to look at this graph, we can see that it says that the airplane is actually landing. So it means it's descending. It's coming from a very high altitude and it goes down. It means that from the highest altitude going down, it means that it's decreasing. Okay, it is decreasing in nature. So for us to get the rate of change in here, let's get these 2 points, these two. Okay, so we're going to get their points. So the first one is actually here 60 and 1000, 60, 1000, and the other is 180 and 0. It means that this airplane has already landed by this time. Okay, so let's look at the change. So I'm going to say this one. I will put that one first. That's gonna be 0 minus 1000 all over 180 minus 60. Okay, so this is going to give you a negative 1000. That's actually the altitude in feet. So 1000 negative 1000 feet all over 180 minus 60 is gonna give you 120. That is time in seconds. So continuing it, it's going to give you a negative 100 over 12, which is actually, we can reduce it to 25 feet, negative 25 feet over 3 seconds. Okay, so let's look at this one. So it means to say that if we're going to explain the rate of change, it means to say that every 3 seconds, the plane is descending 25 feet. That's what it means if you're going to be understanding the rate of change of these specific examples of an airplane landing. Find the slope of each line. So in this case, before I'm going to do the first example, I would like us to show the formula for slope. So slope is actually we call it the rise over run. Okay, rise divided by the run, and that is actually equal to the vertical change. We call it vertical change over the horizontal change. Now, in its grandest form, the slope formula is actually represented by m. Okay, that's going to be m is equal to y2 minus y1 all over x2 minus x1. Okay. Okay, so let's look at this first example in finding the slope. So if you're going to notice in here, there are 2 points. These 2 points in there, it's actually negative 2, 1, and the other point is 3, 4. So we're going to label this one as your x1, your y1, x2, and then y2. And using the formula, y2 minus y1 all over x2 minus x1, so it's going to find you or give you your slope. So in this case, this is going to be 4 minus 1. This is going to be there. And your x is below. That's going to be 3 minus 2. So if you're going to do this, that's 4 minus 1 is 3 over 3 plus 2 is going to be 5. So the slope of this is 3 over 5. Now let's try to look at it if it is 3 over 5. So from here, I would like you to be with me for a bit here. So if we're going to stay from here, we go up 1, 2, 3. That's actually the rise, yeah. It's going to be rising this way. and then it runs this way. Okay. Okay, so say from here 1 2 sorry 0 1 2 3 4 and 5. So this is going to be 5. This is 5 units. Okay, this is actually 5 units in there down there. This is 5 units and this is 3 units. So that's where we can say the vertical change divided by the horizontal change in here. Okay, let's do the next example in here. So we are given 2 points again in here. Our 2 points are actually at -3 and then 2 and 3 1. So let's label this one. Let's say that this is going to be our x1, our y1, x2, and then this is going to be our y2. So putting it in our slope formula, y2 minus y1 over x2 minus x1. Okay, filling the information, that's going to be 1 minus 2 all over 3 minus minus 3. So this is going to give you negative 1 all over, that's 3 plus 3 is going to be 6. Okay, so the slope of this is going to give you negative 1 over 6. Now let's look at it clearly again. So if we're going to be looking at from this point, okay, this is this time not a rise, but it's going to be a down part. That's going to be 1 unit. Okay, this is going to be 1 unit. And then the run, if you're going to be looking at the run is from here to this point. Okay, here from that point going to this point. So let's count how many units there from here. That's going to be my 0. This is going to be 1 2 3 4 5 and 6. So this is going to be 6 units run, and this is going to give you actually 1 unit run. So that's going to give you 1 over 6, and it's negative because it actually went down. Okay, let's go for finding the slopes using 2 points. Here we are now going to continually use our formula. So our formula here is going to be, for slope is going to be m is y2 minus y1 over x2 minus x1. So in this case, we have our x1, y1. This is going to be our x2, y2. So filling up the information is going to give you 7 minus 1 all over 5 minus negative 2. Okay, so this is going to give you 6 over 5 plus 2 is going to give you 7. So the slope of these 2 points is going to be 6 over 7. Okay, horizontal lines. So let's look at the case of a horizontal line. What's going to be the slope of a horizontal line? So there are 2 points in here. Okay, that's going to give you 1, 2, and then 4, 2. So let's see. Our slope is going to be here. 2 minus 2 over 4 minus 1. So that's going to give you 0 over 3. Okay, so 0 divided by any number is going to give you 0. Okay, so what does it mean? It means that there is really nothing happening. It's not increasing, it's not decreasing, but nothing is happening in this case. That's why it's called the slope is 0. Now let's look at this vertical line. Okay, what's going to be the slope of this vertical line? So let's try looking at it. The first point is this one, the second point will be this one. So it's going to give you 4, 2, and the other point is located at 4, negative 1. So my slope is going to be negative 1 minus 2, okay, divided by 4 minus 4. So here we go, negative 3 over 0. Okay, so this is gonna tell me something here. This is called undefined. Now, remember this one, a short keynote. When you're going to be dividing a number divided by a 0, okay, so you can see that there is a letter form in there. It's no. That means in mathematical terms, it's called undefined. It means that you cannot divide a number with a 0. But on the other case, in this case right now, you can see that in here, you can actually divide 0 by any number, then it's still going to be 0. So remember these two keywords. If it is on 0 divided by a number, that's going to be a number. But if it is a number divided by a zero, it is actually what you call undefined. Therefore, for this situation, the slope of this vertical line is going to be called undefined. Okay. Okay, so let's look at the summary of our slopes today that we have taken up in this short practice. So if you're going to be looking at this line, it's actually going up. Yeah, that's going up. So it means to say that here the slope is going to be positive. Okay, going uphill. So the keyword in here is going to be uphill. Okay, now the second one is going to the opposite of that uphill, and it's really actually going downhill. So the slope in here is going to be negative. So this is going to be downhill. Okay, the next one, we just have seen it earlier, that if it is a horizontal line, so just like this one, okay, we can see that the slope is 0. Then we can conclude that the slope of a horizontal line is equal to 0. It means to say it's static, there is no change at all. And last but not the least, if you have seen earlier with our situation in here where the slope is totally vertical, it's actually called undefined. So it means to say that the slope of a horizontal line is undefined. Sorry, it's not horizontal, it's vertical line is undefined. Okay, this is for vertical lines. Okay, so let's look at these practice problems. Okay, the rate of change is constant in each of table and graph. Find the rate of change and explain what the rate of change means for each situation. Okay, number one. So in our x value, we have the time, and the next is going to be the temperature. So let's look at the change in the intervals first. So for the x, that's going to be the time. From 4 to 1, it's going to give you 3-hour difference. 7 to 4 is going to be 3-hour difference. 10 and 7 is going to be 3, and from 13 to 10 is still going to give you, so they are have equal intervals, okay, which is 3. So in here from 7 to negative 2, it's going to give you 9. Yeah, that's going to give you 9. Here from 16 to 7, it's also going to give you 9. 25 to 16, it's also 9. And 34 to 25, it's 9. Okay, so let's use our slope formula for you to understand, but there's also a shortcut in here. If you're going to look at the change in, we call it that this one, delta y, or change in x, it is the same as your y2 minus y1. But in this case, what I did is I first solved this one. So I'm going to say 9, that's going to be 9 degrees Fahrenheit divided by 3 hours. So it's going to give you 9 divided by 3 is going to give you 3 degrees Fahrenheit per hour. Now we are asking here to explain what the rate of change means for each situation. So in this case of situation, there is a 3 degrees Fahrenheit change every hour in this table. That's what it means. Okay, let's look at number 2. For number 2, we have a graph in here where the x represents the miles traveled and the y represents the fuel tank in gallons. So the first thing we're going to do in here is actually to get some points in here. I can see that I can get that point and also this point, which is actually on the top. That's going to give me 0, 15. Okay, and the other point is located at 150 and 5. Okay, so let's get our slope for that. So this is going to give me y2 minus y1 over x2 minus x1. Okay, so this is going to be our x1, y1. This is going to be our x2 and y2. So in this case, this is going to give you 5 minus 15 gallons. Okay, all over 150 minus 0 miles. Okay, so we're going to simplify this one. This is going to give you negative 10 gallons all over 150 miles. So cancel this one. So therefore, the slope in here is only going to give you negative 1 all over 15. So, okay, this is going to give you gallons per miles. Okay, so what does this mean? It means to say that for every 1 gallon, okay, there is a decrease of 1 gallon per 15 miles. That's what it means. Okay, let's go for this next example in here. So if I'm going to look at this one, this is actually emissions. This is generating electricity for TV use. So there are 2 points that I chose in here. The first one is the very beginning, which is at 0, 0. And the other point is actually located at 3, 2 because they are perfectly intersecting each other with x and y. So if you're going to find the slope in here now, the slope is going to be y2 minus y1 all over x2 minus x1. This is going to give you 2 minus 0 over 3 minus 0. So our slope here is going to give you 2 over 3. It means to say that there's going to be 2 pounds per 3 hours of use. Okay, so 2 over 3 pounds per hour. That's what the explanation of the rate of change here. Okay, let's go for the next. Find the slope of each line. Okay, we are asked to find the slope of each line. But I can also say that the slope here is positive. Okay, the slope is positive because the line is actually going up. But if I'm going to really get the main slope of it, then I need to get 2 points from here. Maybe this point, 1, 0, and maybe this point. That's gonna give you 1, 1. Okay, so this is going to be my y2, this is my x2, this is going to be my x1, this is going to be my y1. Okay, y2 minus y1 all over x2 minus x1. This is going to give me 1 minus 0 all over 1 minus minus 1. So that's going to give me 1 over 2. This is going to be simplified as 2 because of the negative. Negative times negative will become positive 2. So that's going to be 1 plus 1 is going to give you 2. So the slope of this line is 1/2. Okay, let's look at this one. So if we're going to be looking at our summary of our slope, I can say that the slope in here that I can see is actually negative because the line is downhill. Okay, it's actually downhill. But let's compute our slope here. So first I'm going to get maybe this line here and this line here. I mean that line, that points I mean. Okay, so if I'm going to get these points here, this point here is going to be, this is 1, 2, 3, that's going to be 2, negative 2 actually. That's going to give you negative 2, and then it's going to give you negative 2. This point is going to be negative 3, and then 1. Okay, so let's continue now with our formula. So this is going to be our x2, y2. This is going to be our x1 and y1. So y2 minus y1 all over x2 minus x1. My y2 is going to be negative 2 minus 1 divided by my x2 is negative 2 also. And then my x1 is negative 3. That's going to be minus 3. Okay, so this is going to be negative 3 over negative 2 plus 3. Okay. Why plus 3? Because the two negatives there will be multiplied together. It will result to positive. Now, this is going to be negative 3 on the numerator. Negative 2 plus 3, that's going to give you only 1. Okay? Okay? So this is going to be negative 3 only. So the slope of this specific line in this case is going to be 3. Now let's try if it is true, because remember that our slope is also going to be the number of rise over run. Now, rise, if it is going to be positive, but it's going to be a descent, we call it going down when it's going to be a negative. So in this case, it's negative. So we're going to be starting from this point. So if I'm going to count from Let's say from this point, yeah, okay, 1, 2, 3. Okay, this is actually 3 descents, and then how many run to this point? It's going to be only one. This part is only one run. So here the rise is, I mean, the going down, not rise this time, is going to be 3 and 1. That, let's make this negative because it's going down. Therefore, it's only going to give you -3, which confirms our equation. So this is all for the lesson on rates of change and slope. If you find this video helpful, share, like, and subscribe. Thank you very much.